So guys, if I want to perform the entire experiment, the first thing we need the data. Now you can ask me where I will get the data. So just go to the Kaggle website. So just search for red wine quality data set Kaggle. So Kaggle is already having that data. You can already download from. So you can download this data from the Kaggle website. So you can see this is the data. And here is the CSV file, guys. You can download this data. Okay, it's around 26 KB kilobyte around. And it is having all the features. The feature actually I showed you. So based on that, actually I have to predict the quality of the wine. Okay, this is the idea. Fine. So to just try to download the data, I already downloaded the data. Let me show you. So let me also give the dataset link in my notebook so that you can also download later on. So here I can mention data link. Okay, so if you click here, you will get the data. Now for me, I already downloaded the data. Let me just create a data folder here, and inside that I will move my data. So guys, as you can see, I already moved my data inside data folder, and this is the wine quality red CSV, and this is the entire data. Okay, now I have to load the data inside my this notebook. Okay, so for this, let's write the code. So first of all, I will import operating system library. I'll select my environment. Okay. Then if I show you my project working directory right now, so let's say pwd, you can see I'm inside research folder. But my data, it is present inside my project working directory. That means this root folder. This is my root folder, guys. Always try to remember whenever you are implementing any project, implement inside your root folder. Okay. So now currently I'm inside a research folder, but I have to come back inside this root folder. For this, what you can do, you can use this syntax. You can just write os.chdr. That means change directory where I want to go back one folder back. So for this, just keep .. Okay, now if I see execute, now I'll be present inside my root folder. Okay, now see wine quality prediction folder. Got it. Now I can easily access my data. So first of all, let me import pandas, because with the help of pandas we'll be loading the data. It's a CSV file, right? Now you can define the data path, data underscore path. So data is present inside data folder /. So you can copy the name. You can mention it here, .csv. Okay, now let's load the data. So I'll just write wines is equal to pd dot read CSV. I think you already know these kinds of basics of data analysis, how we can perform. You have already learned in your machine learning, right? So here I'm not going to perform like so many EDA, so many feature engineering. I'll tell you whenever we'll be implementing advanced kinds of project, that time how it can be done. But here I'm showing you the implementation, how it can be done. One simple, let's say, problem statement, how we can implement in an end-to-end manner, how we can implement in an attractive manner, so that if anyone is seeing your, let's say, implementation, they will get impressed. Let's say if anyone seeing your work, they will get impressed for sure, because so far notebook experiment is there, notebook is there, right? It's not that much of attractive, but if you're trying to convert this notebook to the modular coding, okay, so definitely people will be impressed on your work, right? Because you have done the entire pipeline creation and all. And this concept you can use for implementing any kinds of project. This is my main intention here. I need to show you the end-to-end pipeline creation. Or a problem statement, you can take anything. The things you have learned so far, you can use the same, like, let's say I'm in skill here. Whatever data analysis, whatever feature engineering you have learned, you can use the same concept, but only you just need to learn how we can convert them to the end-to-end representation, end-to-end pipeline. That is my intention here. Okay. Now inside that, let me pass my data path. Okay, so it will give you the data. So if I show you my wines.head, so this is my data, guys. You can see. So this is the quality of the wine, and these are my features. Okay. So these are my independent features, and this is my dependent features. Okay, because it's a supervised learning. Now, if you want to check the information of your data, you can use the info function. It will give you the entire information, the data type, okay, whether you are having a null value or not, everything it will give you. Even it will tell you how much memory it has used. If you want to get the statistical, let's say, analysis, you can use describe function. It will give you the entire statistical actually representation, like what is the count, mean, standard deviation, mean, okay, 20% quantile, 50% quantile, 75% quantile, as well as the max value. Okay, this is the entire data representation. So I think you already know. I don't need to explain. These are the EDA part. These are the simple EDA part we have already learned in your machine learning. Okay, I'm expecting these kinds of prerequisite. Now, if you want to check any missing value, I can use this one. So is null sum. So there is no missing value inside my data. It's completely fine. Now, if you want to plot them, so you can use matplotlib to plot the data. So you can see I'm plotting the histogram here. So this is the entire histogram. So you can see the data distribution. So most of the column are normally distributed, but some of the column you can see these are squid column. Okay. You can also perform different transformation to bring them to the normal distribution, but it's a basic problem statement. We don't need to do it. Okay. We can simply train the data. See here, my main intention is not to show you how to create a good model. Instead, how to create the entire end-to-end pipeline. Okay. Good model you can create. You can apply so many EDA, so many feature engineering. You can create a good model. You can get a good accuracy. Okay. For this, you can refer Kaggle notebook, how people are doing the EDA part, how they are doing the feature engineering part. Based on that, you can gain the higher accuracy. And the same analysis, the same, let's say, code you will be writing for the feature engineering EDA, the same code you can write in your pipeline as well. Okay. Now, simply let's do the 10 test split of our data. So I'll import the 10 test split from the sklearn. Then after that, then I will get the X data and Y data. You can see I'm getting, so you can see I'm dropping the quality because quality is my dependent. I don't need the quality inside my X, and here I need the quality. Now it will give you the X and Y. So this is the X data. And if you want to see the Y data, this is also your Y data. Now let's perform the 10 test split. So it will give me X10, X test, Y10, Y test. So here I'm performing 0.2. That means 20% data I'm keeping for the testing and 80% data I'm keeping for the training. So this is my final results. Okay, after doing the 10 test split. Got it? Okay. Now here I'm going to use one model called ElasticNet because it's a regression problem statement. You can use a linear regression. You can also use, let's say, decision trees regression, different regression algorithm you can use. But here I'm going to use ElasticNet because ElasticNet is a regularization algorithm. Here you will get regularization parameter as well. I think if you go to the ElasticNet documentation, so just search for Elastic sklearn. So you can see it is having different parameter, alpha value, L1 ratio. Okay, then these are the parameter it is having. So you can tweak, these are the parameter, alpha value and L1 ratio if you want to perform the let's say this regularization technique. Okay, so that's why you can see I'm using ElasticNet here so that I can show you the parameter part as well, how we can play with different parameter. Instead of hard code them in my let's say pipeline, I can read from the YAML file. Okay, this is what I want to show you. So let me import ElasticNet. Now let's initialize my model. So you can see ElasticNet. Inside that I'm giving parameter alpha, L1 ratio and random state. Okay, these three parameter, alpha, L1 ratio, and there is another parameter called random state. Okay, this one. Got it? So then I'm feeding my data. You can see X10 and Y10. So it will train my model. Here I got my model. Now if you want to calculate the accuracy, so you can import, these are the metrics like mean squared error, mean absolute error, and R2 score. Okay, so let me import them. Then let's create a function. The function name is evaluation metrics. So it will give you RMSE, MAE, and R2. Okay, so it will take your actual value as well as the predicted value. So let me pass and let me get the matrices. So you can see I'm predicting on top of my test data, and this prediction result I'm passing to my evaluation metrics as well as the original one. So it will give me R2, MAE, and this RMSE. Okay, now if you want to visualize them, you can also print them here. Now see guys, this is my results actually I got. So R2 score I'm getting 25%. So you can also improve the let's say performance of the model by adding some feature engineering here, but I'm not adding because I'm telling you it's the basic implementation we are doing. Okay, going forward, whenever we'll be doing the like advanced implementation, that time I'll also add different kinds of feature engineering technique as well. So this is the entire notebook experiment of our project, guys. So I think so far you are clear. Okay, so far you are clear with the Jupyter notebook implementation. Now we'll be using the same concept, then we'll be creating the entire pipeline. Okay, this is my main idea. So now guys, the first thing we'll be doing the data ingestion. There are data ingestion component. That means we'll be ingesting the data from a URL. Okay, so this is what actually we'll be implementing. But before that, let me commit the changes, whatever, let's say new changes I have done. I also need to push to my GitHub. So now you can also push from the VS Code itself. So there is a button called source control. Just try to click here and make sure, first of all, you have to connect your GitHub with your VS Code. Okay, then you will be able to do it. So here you can give the commit message. So let's say I'll give notebook experiment done, commit, then push the changes. That's it. Now if I go to my GitHub and refresh, you'll see that all the code has been updated. Okay, all the command has been also updated. Fine. So now let's do the data ingestion experiment, like how we can ingest the data. First of all, again, we'll be learning in the Jupyter notebook. Then we'll be converting everything as a modular coding.